Welcome back to JVM Internals Crashcasts. I'm your host Sheila, and today we're diving into the fascinating world of class loading and linking in the Java virtual machine. We're continuing our journey through the core concepts chapter in our JVM novice series. Victor, are you ready to unravel this crucial aspect of the JVM?
Absolutely, Sheila. I'm excited to explore this topic with our listeners. Class loading and linking are fundamental processes that happen behind the scenes every time we run a Java program.
Before we dive in, let's start with a quick quiz for our listeners. Here's the question. In the JVM's class loader hierarchy, which class loader is responsible for loading the core Java API classes? Is it the Bootstrap class loader, the extension class loader, or the application class loader? Think about it, and we'll reveal the answer at the end of the episode.
That's an excellent question, Sheila. It really gets to the heart of how the JVM manages and organizes classes. I'm curious to see how many of our listeners can get this right. It's not as straightforward as it might seem at first glance.
Agreed, Victor. Now, let's start with the basics. Could you give us a brief overview of what class loading and linking are, and why they're important?
Certainly. Class loading is the process of locating and reading class files into the JVM's memory. Linking, on the other hand, is the process of taking those loaded classes and preparing them for execution. These processes are crucial because they ensure that all the necessary code is available and properly set up before it's executed.
That makes sense. So, class loading is like gathering all the ingredients for a recipe, and linking is like preparing those ingredients before we start cooking. Can you walk us through the class loading process in more detail?
Great analogy, Sheila. The class loading process has three main steps: loading, linking, and initialization. In the loading phase, the JVM searches for and reads the class file, creates a class object to represent it, and stores the class's binary data in the method area.
Interesting. And what about the linking phase? I've heard it has multiple steps as well.
You're right, Sheila. Linking consists of three sub-steps: verification, preparation, and resolution. Verification ensures that the loaded class file is structurally correct and adheres to the Java language specifications. Preparation allocates memory for class variables and initializes them to default values. Resolution is the process of replacing symbolic references with direct references to the actual memory locations of classes, methods, and fields.
Wow, that's quite a process. It reminds me of how a library might process new books. They verify the book's condition, prepare a space on the shelf, and then catalog it so it can be easily found later. Is that a fair comparison?
That's an excellent analogy, Sheila. It really captures the essence of what's happening during class loading and linking. Now let's talk about something that often confuses developers: the class loader hierarchy.
Oh yes, I've heard about that. There are different types of class loaders, right? How do they work together?
Correct. The JVM uses a hierarchical structure of class loaders. There are three main types: the Bootstrap class loader, the extension class loader, and the application class loader. They work in a parent-child relationship with the Bootstrap class loader at the top of the hierarchy.
That's interesting. Can you give us an example of how this hierarchy might work in practice?
Sure, let's say you're running a Java application and it needs to load a class. The application class loader, which loaded your application classes, will first delegate to its parent, the extension class loader. If the extension class loader can't find the class, it delegates to its parent, the Bootstrap class loader. Only if the Bootstrap class loader can't find the class will the extension class loader attempt to load it, and so on down the hierarchy.
I see. So it's like a chain of command with each class loader checking with its superiors before taking action. Are there any common pitfalls developers should be aware of when it comes to class loading?
Absolutely, Sheila. One common issue is the class not found exception, or no class def found error. These can occur if the class loader can't find a required class. Another pitfall is having multiple versions of the same class on the class path, which can lead to unexpected behavior. It's crucial to manage your class path carefully to avoid these issues.
Those sound like tricky problems to debug. Do you have any tips for avoiding them?
Good question. Some best practices include keeping your class path clean and well organized, using build tools like Maven or Gradle to manage dependencies, and being cautious when using custom class loaders. It's also helpful to understand the class loading process when debugging these issues.
That's great advice, Victor. Now, I've heard about something called dynamic class loading. Can you explain what that is and how it relates to what we've discussed?
Certainly. Dynamic class loading is a powerful feature of Java that allows you to load classes at runtime rather than when the program starts. This is done using the class.forName method or a custom class loader. It's particularly useful for plugin systems or when you want to load classes based on runtime conditions.
Fascinating. It sounds like it adds a lot of flexibility to Java applications. Before we wrap up, let's reveal the answer to our quiz question. Victor, would you like to do the honors?
Of course, the answer to our quiz question is the Bootstrap class loader. It's responsible for loading the core Java API classes from the rt.jar file. Interestingly, the Bootstrap class loader is actually implemented in native code, not Java, and is part of the JVM itself.
Thanks, Victor. To summarize what we've learned today, class loading and linking are crucial processes in the JVM that prepare classes for execution. The class loading process involves loading, linking, which includes verification, preparation, and resolution, and initialization. We also discussed the class loader hierarchy and some best practices for avoiding common pitfalls.
Excellent summary, Sheila. Understanding these concepts is crucial for any Java developer who wants to dive deeper into how the JVM works under the hood.
Absolutely. In our next episode, we'll be exploring runtime data areas in the JVM, another fascinating aspect of its internal workings. Don't miss it. And remember, if you've enjoyed this episode, please subscribe to JVM Internals Crashcasts and leave us a rating. Your support helps us continue bringing you in-depth explorations of JVM internals. Until next time, happy coding.